All right, let's dive right in. In the next few minutes, we're going to build your personal toolkit for data analysis. We're going to equip you with the essential methods to turn raw numbers into really smart business decisions. So here's our game plan. We're going to start with the single most important framework for any kind of analysis. Then we'll start adding powerful tools for prediction and comparison, building all the way up to a final guide that shows you exactly how everything fits together. You know, every great analyst needs a reliable process. So at the very core of our toolkit is this universal 5-step framework for hypothesis testing. Think of it as the master blueprint for pretty much any analysis you'll ever run. This 5-step process, it's basically the instruction manual for everything we're going to discuss. It's a really disciplined approach that takes you from a simple business question to a reliable, data-driven answer. Following these steps keeps you from jumping to conclusions, and honestly, it's the key to truly confident analysis. Okay, so we've got our universal framework down. Let's add our first real tool. This one is all about answering questions about the future. It's for prediction. And we're going to start with the cornerstone of all predictive models, linear regression. So this right here is simple linear regression, or SLR for short. It's a precision tool for really figuring out the direct relationship between two variables. Like you see in the graph, we're trying to find that one perfect straight line that answers a question like, hey, if we increase our ad spend, by exactly how much can we expect sales to go up? But, and this is a big but, before you can trust that prediction, your data has to pass 4 critical checks. You can remember them with the acronym LINE. Seriously, think of these as a quality control inspection. If your data fails any of these tests, say if the relationship isn't a straight line, your model's predictions are going to be unreliable. And that means any business decisions you make will be flawed. I mean, in the real world, right? Outcomes like sales or stock prices are rarely driven by just one single thing. So what do we do when we need more predictive power to capture all that complexity? Simple. We upgrade our toolkit. As you can see here, we move from that simple straight line of SLR to this awesome multidimensional plane of multiple linear regression, or MLR. This upgrade is super powerful because it lets us model the combined effect of several factors all at once. So now we can see how ad spend, website traffic, and seasonality all work together to predict our final sales number. Now, with more predictors comes one more really important check. We add an M for multicollinearity to our dashboard, and this test is absolutely crucial. It makes sure our predictors aren't redundant. Basically, it checks if we have 2 instruments in our orchestra playing the exact same note. We want to make sure each one is providing unique information to our model. Okay, time to shift gears from prediction to comparison. Let's say your business question isn't how much will sales be, but it's more like, did this new website design actually lead to more sales than the old one? For this, we're going to need a new tool, one for comparing the average performance of 2 different groups. The t-test is your absolute go-to tool for these kinds of A/B comparison questions. It rigorously tests whether the difference you see between 2 groups, say sales from 2 different website designs, is a real significant effect, or if it could have just happened by random chance. And yep, you guessed it, just like regression, t-tests have their own quality control checklist, which we can remember with the acronym INEO. And running these checks is totally non-negotiable. For instance, if your groups have a wildly different spread of data, just comparing their averages can be really misleading. These checks make sure our comparison is fair and our conclusion is trustworthy. So a t-test is fantastic for 2 groups, but what if you're comparing a new website design against, say, 2 old versions? Or maybe comparing the performance of sales teams across 3 different regions. For that, we need to upgrade our comparison tool. This visual just nails it, doesn't it? It perfectly captures that jump from a t-test to ANOVA. We're upgrading from a simple 2-pan scale to a system that can weigh multiple groups all at once. And the key thing here is that ANOVA first gives us a simple yes or no. Is there any significant difference to be found somewhere among all of these groups? So how does ANOVA find that difference? Well, it acts kind of like a radio tuner. It separates all the variation in your data into 2 frequencies: the clear signal that's caused by the differences between your groups, and the background static, or noise, that comes from random variation within each group. If that signal comes in loud and clear over the static, we know we've found a real difference. So we've done it. We've assembled our core toolkit. We have our universal framework and specific tools for both prediction and comparison. The final and most crucial step is to create a simple decision guide so you always know exactly which tool to grab for the job. And this guide boils everything we've covered down into one simple table. The most important question you should always ask yourself is about your goal. Are you trying to predict a number or compare groups? Once you answer that, this table points you to the exact right tool for your data. This is your practical roadmap to analysis. And here's the bottom line. You're now equipped to go beyond just looking at data. You have the methods to interrogate it, the power to build predictive models, and the structure to run effective experiments. Ultimately, you have what it takes to drive strategic business decisions with real confidence. So we'll leave you with this. These aren't just abstract theories. They're practical, powerful tools. They're just sitting there in your toolkit, ready to be used. The only question left is, what problem are you going to solve first?